just having a look at some of the things that you've been doing over the past few days, and also conversations I've had with a couple of you as well. I thought it might be useful just to go through a couple of things to do with ellipses and hyperbolas before moving on to the next thing. So this is a quick video, a bit of a recap, and maybe another way of looking at a few bits and bobs that might be helpful. Okay, so let's just start with a couple of things that hopefully you'll be quite pleased to hear about. So what I've got on the screen here towards the right-hand side, these things are given. All right, when you start doing the internal, you get given these formulas. So you get given the form of the ellipse, you get given the form of, lost my thing, you get given the form of the hyperbola. Remember, the difference between these two things is there's a plus, there's a minus. Okay, we've got the parametric forms we're given as well. Foci, we always say they're plus or minus c and 0 in both cases, and the eccentricity for both cases is this c value divided by a. That's fine, you get given that. The other thing just to note here, we've got this connection between a, b, and c. This formula holds for an ellipse, and again for a, b, and c for a hyperbola, we've got a very similar looking formula. The only thing that's changed, okay, in here is rather than being a squared minus c squared, we've got c squared minus a squared. Now you might think, how do I remember which one to use? Well, you've got given these, so hopefully you'll be fine. You won't have that confusion. But if you do, at any point, if you use the wrong one, you'll get an answer that doesn't make any sense. Okay, you might end up having to square root a negative, and you can't square root a negative. It tells you did the wrong thing. All right, so just make sure that if you get that kind of thing happening, to square root a negative, it means you chose that the wrong way around. It should have been c squared minus a squared rather than a squared minus c squared, for example. One other thing I'll just sketch on here that it doesn't give you, but if you did want it, the equations of the directrices, well, the directrices are always the same. In both cases, just the way the eccentricity is the same, you can just do a divided by e, plus or minus. Okay, so here again, if you want the directrix, you're going to say that's plus or minus a over e. That's not given. If you think it's going to be useful to you at some point in the internal, you know what to do. Cheat sheets are the way to go, aren't they? Get it on the cheat sheet. Okay, I just wanted to go through this one particular question because I think it's quite useful. And I think it highlights a few things that a couple of you have been asking me about. So I'm going to take a hyperbola in particular here that is expressed with the y's to start with rather than the x's, and also has its center moved. Okay, so the center of this hyperbola is not the origin. The center is moved because we're doing some things, we're subtracting some things from y and from x before we are doing the squares. So we've got it in the standard form. What I can tell straight off from this is that, and I'm still going to call this thing here b squared. The thing y squared is always over b squared. Okay, and I've swapped them round, but I'm still going to stick with it that way around so it doesn't confuse anything else I might want to be playing with. So I'm going to say y squared is still over b squared, and the x squared bit is still over a squared. So I'm able to say that b is 4 and that a is 3. Okay, just the same as I would have done before. I can read off where the center of my hyperbola is going to be, because just the same with the ellipse and with the circle, if I'm subtracting something away here, that's telling me, be careful, this is the x coordinate bit, so that's going to tell me the center is at 2, 1. Okay, that way round. The x was having the 2 subtracted from it, the y was having the 1 subtracted from it. What else can I say? Well, I'd like to be able to say where the vertices are. And because this time it's the y that's at the front, having the x bit subtracted from it, the vertices are going to be in the y direction. So I'm going to start to do my little sketch now. My vertices are going to be in the y direction. Let's start with what we know. We know that the center is at 2, 1. So let's say that's 2, 1. I said 1 as I was writing that, didn't I? Which is why I've gone a bit wrong. So that's 2, 1. Okay, and my center is in that position. Okay, now because I've shifted all along in this way, usually what would happen, because my vertices are in the y direction, is that I would go 4 above to get where that one is. So I'm going to say that's 5. Yeah, so this distance here to that first vertex has got to be 4. And this distance down here would have to be 4 as well. So that's going to move to a -3, isn't it? From the 1, it'll take me to a -3. So they're my 2 vertices. Okay, this is my center. Now my asymptotes are going to go through that center, aren't they? But before we go about doing that, let's work out where the focus is. So the focus, we know, because we're dealing with a hyperbola, we're dealing with b squared is c squared minus a squared. Now at this point, I'm just going to stop, because this is the form that we would use if we were dealing with the x squared over something minus y squared over something. That's what all this is about down here in the bottom right-hand corner. I've got to now think that what's actually happened here is where I had x before, I've now got y. X and y have swapped positions in the same way that a and b have swapped positions. So everything I write down, I have to think, swap the x for a y and swap the a for a b, and vice versa. Swap y for an x and b for an a. So in this formula here, I swap the b for an a. C, okay, fine, let's stay where it is. And I'll swap that, because that's all we've done. We're just dealing with our axes the other way around, and we've swapped variables, so we've got to just swap those around. But notice, it's telling me the same thing, really. I could just rearrange that back to say that b squared is c squared minus a squared again. Okay, now I'm actually going to put that bit in quotes there, because I'm saying that's the sort of standard form that I'm looking for if it was the other way around. But in my case, it would be this. But it gives me back the same thing. So the nice thing for us to bear in mind about all of this, okay, it's coming my pointer, is that this thing does not change if we flip the order of x and y. It's still b squared is c squared minus a squared. All right, let's stick our values in. So b squared was 16. C squared we don't know. A squared was 9. So I think that means to me that c is 25 square rooted. Okay, because I had the 9 on and then square root. So c is 5. I now know that the distance from the center then to this focus and the distance from the center to this focus, they're both 5. Actually, it's moved 1 on, hasn't it, from where the vertex was. So there's a focus. And again, at -4, I'll have another focus. All right, if I wanted to from here, I could work out my eccentricity, because I know my eccentricity is just c over a. Actually, let's just write it out. Eccentricity is c over a. Remember, though, in this case, we have swapped a's and b's. So our eccentricity must be c over b in this case. All right. So our eccentricity is going to be 5 over 4. Yep, our eccentricity is 5 over 4. So we've done that. What else might we want to do? We want to know where our asymptotes are. And again, I'm going to do this thing here where I write down the usual form before I think about the fact that I've split off and change my x's for y's and my y's for b's. Now what this gives me is going to give me then, okay, sorry, I didn't mean to write that there. Let's swap the things over. So the a's become b's, the b's become a's, the x's become y's. So we get that. Now if I rearrange this, if I multiply it by b, onto the x side, I've got plus or minus ay. If I now divide by a, I've got b over a x is plus or minus y. So what I've got is y is plus or minus b over ax, which is just what we had at the start. So like with the b squared equals c squared minus a squared, b squared is c squared minus a squared, like with that, this thing does not change. Y is always plus or minus b over ax. So that's quite nice. Okay, so for my asymptotes down here, this expression always holds, even if I flip the x and the y over. However, I've got to be a little bit careful here, because this is the form if my asymptotes go through the origin. These asymptotes don't go through the origin. Well, I can't say for sure that they do. They probably don't, because they go through the new center point, don't they? Yeah, the asymptotes, everything shifted from that origin to here. So where my asymptotes would normally do that, my asymptotes now have got to go through this point 2, 1. The gradients are still going to be the same, though. They're not going to have altered. So let me go back to my pen. The gradients are not going to have altered. So I know, and I know that every straight line goes like this, y equals mx plus c. The gradient has not altered, so it's still going to be given by plus or minus b over a. So in this case, y is plus or minus b over a, 4/3, x plus a constant. And now I just need to work out what that constant is in each case. So let's start with y equals 4/3 of x plus c. Now I know a point that's on that line. The center is on that line, 2, 1. The asymptotes are going through that center, remember. So I'm going to use my point 2, 1 to see what that's going to tell me that c is. So in that case, y is 4/3 of 2. Okay, 8/3 in. 4/3 times 2 plus c. And my y value, actually let's just scrub that in there straight away, put that as 1. And my y value is 1. Take away 8/3 from 1, and we've got c. All right, 1 is 3/3. Take away 8/3. We're going to get c is minus 5/3. Okay, so one of my lines, let me write him up here, one of my asymptotes, I've already determined then, taking the plus 4/3, we subbed into that one, didn't we? And that's a minus 5/3. Okay, what do I get from the other one? Let's bring out the other one. So again, we use 2, 1, but this time we've got the negative gradient. So this situation, 1 is equal to minus 4/3 times the x-coordinate. That's minus 8/3. Yeah, you see the only change that's happened between the line above and this line is that that's just become the negative, what it was. That was, remember, a 3/3. Now we've got to add on 8/3 to the other side to get the balance. So I get c is 3/3 plus 8/3, 11/3. So my second asymptote is minus 4/3 x plus 11/3. And I could just sketch those on. All right, 4/3 is the gradient. So I can think about where that's going to be. This is 11/3. Yeah, so the negative one, actually 11/3 as an intercept is just a little bit less than 4. It's going to come down there somewhere. So yeah, this is going to be really bad because I'm just not so good at doing this sort of thing at the minute. And then similarly, we've got something going the other way, minus 5/3. It's not quite as far as minus 2, is it? So it's down there a little bit. But again, it comes up like that. So we've got our asymptotes, we've got our vertices, we've got our foci. We know then that our hyperbola is going to do this kind of thing. God, that was pretty poor, that one, wasn't it? More like that. Okay? So we get the idea of what's going on. Hope that's helped. That stuff, though, there on the right-hand side, really, really helpful because you've got given all of that. Yeah, you might want to know where the directrices are as well. But hopefully this example has just helped you with a couple of things where we end up changing the axes round, which way around we're going. We're going in the y direction rather than the x direction, and what happens to all the other forms that we can just quote. All right, so the nice thing is the asymptote equation doesn't change, and the equation we use to get the focus doesn't change. All right, it will stay the same. Okay, good job. See you next time.